In this question from the trigonometric identity, we have to prove that tan theta bar over 1 minus cot theta plus cot over 1 minus tan is equal to 1 plus sec into cosec. Now, what you can figure out that all these trigonometric ratio have some relation with sine and cos, either sine or cos or maybe both. Like tan is what? Sine over cos. Cot is cos by sine. Cot is cos by sine. Similarly, we have sec as 1 by cos and cosec here. As you can see, cosec is what? 1 by sine. So we are going to write all of them in terms of sine and cos, both LHS and RHS. So let's begin with the LHS. If I write LHS, we have LHS as tan theta over 1 minus cot theta plus this is cot theta over 1 minus tan theta is what our LHS. And as I said, I'm going to write all in terms of sine and cos. So this tan is what? Sine theta over cos theta. So this is sine over cos, that divided by 1 minus cot. Cot is what? Cos theta by sine theta. So this is cos over sine. We have a plus sign in between. And then this cot once again can be written as what? Cos over sine. And 1 minus this tan theta once again will be written as sine theta by cos theta. Now, what we are going to do is to take LCM now. In this part, I'm going to take LCM. So let's say this sine by cos is as it is. Sine theta by cos theta is as it is. Now I'm going to take LCM over here. Right. The LCM is what? Sine over here. So if I write sine theta, 1 multiplied by sine is what? Sine. So this is sine theta minus cos theta plus sine. Same we are going to do on the other part of this sum, that is cos theta over sine theta. Numerator copied. Now in the denominator, we have LCM as cos. So I'll take cos theta. And this is 1 minus 1 into cos is what? 1 into cos is cos. So I'll write this as cos theta minus sine theta. Well, it is easy to figure out that I simplified this. I simplified this as this, right? And so is what I have done. So which I have done with this part. I wrote this after simplification as this. Now, once we have done till here, what we are going to do is to simplify it further. And for simplification, we will be dividing both this. By that, I mean to say that, let's say if I do, it will be more clear. So we have a numerator as sine theta over cos theta. But we know here that dividing by this is same as multiplying with the reciprocal. So I'll be multiplying with the reciprocal of this, which is sine theta over sine minus cos. Sine theta minus cos theta. Now, if you put a plus sign here, let's simplify this part. We have cos by sine, cos theta by sine theta. And as I said, we are going to divide with the denominator, and dividing is same as multiplying by the reciprocal. So I'll be multiplying by the reciprocal of this. So it will come as cos in the numerator and cos minus sine theta. Now we have to take LCM, and for taking out LCM, what you can figure out that we have cos theta, sine minus cos, and cos minus sine. To simplify the working, what we can do, we can take minus as common, right? That is minus common from here. I'm going to take out this minus sign as common. Now, if I take this minus sign common, it will influence this sign and it will become plus. So let me show with the working as well what I mean to say. Over the numerator, we have sine into sine, that is sine square theta. So I'm writing this as sine square theta, that divided by cos multiplied by sine minus cos theta. Now, as I said, I'm going to take this minus common. If I take out, once again, I'll show you. I mean to say that I'm going to take this minus common from here. So if I take out this minus common from here, this minus sign will influence this and will become minus instead of plus. This is going to be minus here. Now, after taking minus as common, the numerator, which is cos into cos, will remain as it is, that is cos square theta. And the denominator should be what? Let's say we have one sine, is sine theta only. And what I said, I have taken minus common from here. So this cos minus sine, after taking minus common, sine will become positive and cos will become negative. That means it should become sine theta minus cos theta. Now let's figure out why we did so. This I did so because we can see that we'll have same denominators here, and that will make it easy if I take common, or we may take LCM. So let's say if I take out this common, that is, as I said earlier, that I can take out this common, that is 1 over, I'm taking out 1 over sine theta minus cos theta as common. This will simplify our working. What we'll have now, we'll have sine square theta in the numerator over cos theta. And we have a minus sign. We have cos square theta over here and sine theta. Now we need to simplify this part by taking LCM. Well, other part remains same. So let's say this is 1 over sine theta minus cos theta as it is. And on the other part of simplification over here, I'm taking LCM, which is sine theta multiplied by cos theta. Sine into cos is the LCM. Now you see you have to multiply sine with this. So this is sine cube theta. And this will give you cos cube theta. Here onwards, I'm going to apply this identity over here. At this part, I'm going to apply, that is identity of a cube minus b cube. So what is a cube minus b cube? Let me first write down. A cube minus b cube is what? This is a minus b times a square plus b square minus ab. This is what I'm going to apply in this part. So let's say, keeping rest as it is, that is, this will remain as 1 over sine theta minus cos theta times, as I said, I'm going to apply this identity here, that is a cube minus b cube is what? A minus b, that is a minus b times a square, that is sine square theta, plus b square, that is cos square theta, into minus a cube minus b cube is a minus b, a square plus b square, and then in plus ab, that is plus sine theta into cos theta. Denominators here is what we have denominator of this, that is sine minus cos. So this is sine theta, sine into cos, sorry, sine into cos. Now check here, this get cancelled. You can see that this and this can be cancelled as it is sine minus cos because they are multiplied. So we can see that since they are multiplied, we can cancel them. So I'm cancelling this, and this get cancelled. So what we are now left with, let's say figure out, we need space. So I can minimize this. Yeah, should be sufficient. Now in the next part of the working, what is this? Sine square plus cos square, and sine square plus cos square is 1. So I'll be writing 1 instead of this. So in the numerator, we'll be left with 1 plus there is sine into cos over here. So this is sine theta into cos theta, and that divided by sine theta into cos theta. Further, we are going to split this, and splitting part I can then do it here on the space available. So first I'm writing 1 divided by this. So 1 over sine into cos, sine theta into cos theta plus. So what I'm dividing this by this, which is 1 over sine plus cos. And when I divide these two, I'll get 1, right? Because they are same, sine into cos, sine cos over sine cos. So I'll get 1 from here. Now check what is 1 by sine from here. You can see the formula list. 1 by sine can be replaced. 1 by sine can be replaced with cosec. So we can write cosec for this. So this is 1 by sine is cosec. So this is cosec theta plus. Similarly, what is 1 by cos can be written as sec theta. So I'll write this as sec theta. This is sec theta. And plus 1. Plus 1 is this plus 1. So I can say this is equal to the RHS. If you see RHS, here 1 plus sec into cos. So I by mistake made a plus sign. Let's understand this once again if you haven't got it. So what I did, I wrote 1 by sine as cosec theta into, this is multiply 1 by cos, which is sec plus 1. And that is equal to the RHS. As you can see, this is what our RHS. Well, the order will not make a difference whether I write 1 plus sec into cosec or cosec into sec plus 1. As you know, product is commutative and even addition is commutative.